fashion upskilling innovation open network. Fusion is an international partnership project funded by Creative Europe that took place from April 2020 until April 2022. Fusion program provided selected designers and makers with training in digital fabrication skills and co-designing methodologies essential for the development of bespoke products across fashion, textiles, and wearables for active aging citizens. Active aging aims to extend healthy life expectancy and quality of life for all people as they age. Fusion was set up and delivered by 4 international partners: Limerick School of Art and Design in Ireland, Crafts Council in the UK, Polytechnic Institute of Cavado and Ave in Portugal, and Fondazione Sant'Agata for the Economics of Culture in Italy. Through national call-outs open to a wide range of disciplines including, but not limited to, fashion designers, textile designers, product designers and digital artists, each partner selected 2 applicants. Professional designers, makers with curious attitude, ambition, and a keen interest in pushing the boundaries of fashion and textile design through digital fabrication to participate in the Fusion project that brings traditional fashion and textile heritage expertise to a new cultural audience. Fusion program was developed in 2 stages: masterclasses and residencies. Series of masterclasses was developed by Fusion partners to provide participants with training in digital fabrication skills and co-designing methodologies. Masterclasses were delivered by carefully selected experts, highlighting the economic, social, and cultural variations and distinctions that shape creative business with a focus on active aging as a component and a focus. Each masterclass was facilitated by a different Fusion partner and spanned over 2 days in a form of an online workshop. After completion of the masterclasses, each participant presented their proposed concept for the design with the same overarching themes as the Fusion Creative Europe project to be developed during the second phase of the program. 2 weeks residency programs spread through partner countries and provided participants with access to the full range of facilities, equipment, and support in their assigned institution to complete a body of work. This was an opportunity for participants to explore new studio space and uncommon material processes to develop and refine their skills in order to enhance their profession.
Now it's not exactly right, but because this piece here is all we really need.
After the successful completion of the residency, participants got the opportunity to publicly exhibit their designs to a European audience.
dedicated to design. Our mission is to spread the design culture, and we try to do it through a variety of actions and ways. We produce a cultural program working on talks, exhibitions of course, and workshops mainly. Of course, the themes of our cultural program tries to break boundaries of design and try to let design arrive more directly also to people who don't come from this world. That's it. We're open to the public. We have our headquarters order is this, and maybe we can go through. Yeah.
Good morning, everyone. I think everybody already know my name, but my name is Luisa. I'm very glad to be here. The work that I'm going to present today is entitled Phenotypic Plasticity. For me, as a designer, it's very important to work the concept of the prosthesis as a garment. So in this wearable piece, we have a mechanical upper-wing prosthesis integrated into a garment. This piece was entirely printed through flexible filament here, TPU, polyurethane, and then I applied gold leaf in both sides of the piece. The prosthetic was printed with a carbon-based material, which made it very with good mechanical property. We have haptic feedback here through a handshake. Inside the hand, we have a button made entirely with conductive thread that work as an input. And as output, here we have a speaker that should tell us about a story about my uncle. She is 97 years old. And so this piece always is also about memory, empowerment, and how to register those memories and highlight this.
It's a very beautiful piece visually.
Yeah, stunning.
Pharaonic. Compartments. It's called mind sight, hence recall to mind, using the old English word mind and recite. So it's to help stimulate the memory of those living with dementia, so early onset dementia. This is a prototype, so you'd have a box for each day of the week, and within each box you can put memory cards, prompts, photos, memories, and each box is personalised to the user. So I have used photos and created cyanotypes, so it uses natural sorts, and you can print your own photographs using negatives, and this would be personalised to the user and evoke a sense of memory and remind them of past times and help them remember. So the box is just a simple plywood, and then inside we have an organic cotton 3D printed with plastic, PLA, and it has an accordion pleat, so it expands upon opening, and then we also have the lights, which would, this is a prototype, so it stays on, but it would turn on when you open and turn off when it closes. So it's to engage the senses, to promote a sense of independence, so it can be used by the carers as well as the person living with dementia. And yeah. I was just experimenting with also different forms. Originally I was trying to figure out different structures, how to create the pleating, but I didn't, this is the first time I've done 3D printing, so I didn't understand the notions of it, but I ended up going with the accordion because this would have been too complicated for me to do the skeletal structure to figure it out. And so it started off really basic, and then trying to get different sizes, and then whether to do an ombre. Stuck with, I ended up continuing with the bold colour, because with those living with dementia you need to keep colours bold, simple, and it needs to be contrasting against the wall so that you can place the objects and it doesn't get lost. So, yeah.
Congratulations.
Thank you.
Very good. It was really by my neighbour Grace, who is a very elegant lady, but refuses to put tools down and keeps working away, always getting herself in mischief. And I tend to see her at least once or twice a year with a rather cumbersome plaster brace, and I just wanted to look around that, I suppose, and explore the aesthetics of injury, and something that would be more in keeping with something that she would be proud to wear, embrace the injury, and I suppose not necessarily show it off, but have something that could support her in a more elegant way. So I began, my background is in knitwear and looking at supportive knit structures and how I could pull that through to something that would create, in a way, a sort of a collection of pieces that could support the injured person through all phases of injury. So from something which will need a very rigid supportive brace, through to something that has built-in support through knitted structure, to something that is just gently supportive. So there's kind of a little story of pieces here in a way. The link to the knitwear had me wanting to focus on wool and on Irish wool. When it came to the production and prototyping of these pieces, I moved to a material that is more readily available. There's, I suppose, material adaptations that I'd like to see happening with this down the line. But for now, I still tried to keep it as a material that is compostable, even though PLA polylactic acid is commercially compostable, but it's a corn derivative. So looking at a material that in theory can go back into the earth at end of life, but trying to keep it as a more circular piece as well. So a brace that can be worn and then retained for use again, or just sort of simply as a decorative piece that could exist in the home place and not immediately read as what it is, which is a supportive cast. The sort of system that's built into it is looking at how they could be customizable for each individual user. So the idea of being able to scan the arm, so we looked at modes and methods of doing that, not only scanning the arm but then scanning the knitted structures that I wanted to bring through. So it was a way for individuals to be able to bring through their own sort of textiles and taste into the finished article. So we scanned the arm, these structures, and then 3D printed the pieces. So these two, one is a magnet-based design, which needs a little bit more, I think, power in those magnets, but it's working prototype. And then this piece, which we need to sort of look at as well, but still exploring different ways of actually working with the pieces. But that is where it's up to at the moment.
I think it's brilliant.
Yes.
Very well done.
My fusion project, that it was since the beginning I planned this kind of projects to explore more the design process, and the context is in footwear sector because I have that experience, and it's a kind of project to alert the society, the industry about new process. What can we help the people to don't damage the feet? Because in our life we start to damage the feet, our position, how we walk, and because tight shoes or not so good soles and so on, that starts to damage in the future our body. So, as you can see there, in that PLT, I tried to show 4 stages of the process that normally are not used, or just small parts are used not so often in the industry. So the first thing is a 3D scan of the final user. Of course, I don't know in the future how this can help, or can be used, like with a mobile, maybe everyone can do a scanner, but now it's not possible. We are in 2022, we just all registered the online discourse. And this is interesting because it was very fast. So we did like in 2-3 hours, but the final one, it was like in less than 1 minute. Just because the lights, the background, we had some tests and we didn't catch immediately. But it was really fast, and after the next stage, it was the 3D print. So the residency, it was in Ipcan, and it was really easy because the file, the 3D format, from the scanner to the 3D print, it was exactly the same. The technical, the 3D designer, he didn't touch anything. Just to the position for the 3D printer size, and we have in the pictures and the movies that we put the feet from in this position, right? The model, it was Helena. I don't know if you remember Helena in Portugal, and sorry.
Fine.
And she had, because now she is operation. A few weeks ago.
Surgery, yes.
So she had this problem that in Portuguese is joanetes, in English is
Yeah, bunion.
Bunion?
Bunion.
Bunion?
Bunion.
And as you can see, if all kind of sneakers, shoes, or sandals, with stripes and so on, can damage her. Maybe she has pain just to use the nice shoes that she wants to use and so on. So the idea, it was, this example, it was a chance because I asked her if she can be my model to do 3D, and after I realized she had this problem, and it was interesting for this project. And after this, the 3D printer, we can move to the fourth phase because we are speaking about the upper. It was the last part of the project. The idea is to inform, to mold with some kind of upper and material. So I decided to use a natural fabric like felt, very natural, and to mold exactly the shape of the foot. And like that, this is the base to after cement with sole, and we can cut if we want to do a slipper, or if we want to do a little bit more shoe shape. Of course, there are some limitations. It was a test because we don't have any cuts. The shoes normally we have pieces and we stitch and so on because the feet are really asymmetric shapes and irregular. So it's difficult to do a full piece for the upper. So we need to do some cuts and so on. So it was my idea at the beginning, something simple, sandal. And after I realized that the 3D print to the leg and to do some kind of boots could be very difficult for this stage of the project. So I just stay in the sandals. As you can see, I try different materials. That material on the bottom is not the felt material. It's kind of leather, very soft and so on. I try several and some kind of liquids and glue and so on, just to keep the shape and to give an idea that maybe the industry can study a little bit more about this kind of materials to do this kind of shape. And after I had an industrial partner to do the soles. It's a 50% recycled rubber. So I tried to do more, like 80% recycled, but they say it will be difficult because the material don't have a plan to keep connect with the other part of the rubber that is not recycled. So I have here some examples, as you can see. And I thought to do installation for this project. But okay, it's stages. There are several steps. What can I do? I put the 3D scanner here, the 3D printer here. No, it's not so nice. So I try to do like an industrial mass production. It's a mini production, but natural, and to give the feeling of everything is natural. We don't use toxic materials or process. Of course, this is the beginning, just the beginning, and I hope this project can be communicated to give some ideas to the industrial, to the final clients, and so on. And of course, in my PhD, also I will speak a little bit about this project in my PhD, because I'm doing about design culture evolution in the industry. So one part, a very empirical, experimental project, I would like to share a little bit about this because with the industry we speak a lot about innovative process, because sometimes we think traditional sector, but it's not that. It's a sector, for example, food industry, and there are traditional process and innovative process. And they can experiment more. We just need to give some tools, some ideas, and maybe someday they change, they experiment, they have that opportunity. And that's it. Thank you. Thank you for all the support you gave us, and also the colleagues. We learn a lot each other. Yeah. I think it was really nice.
It's your I'm Maggie, and my project is based on me and my special friends. So my own background is product engineering for textiles, and especially in underwear. The last 4 years I've been working on integrating electrodes, silver print, silver ink, silver wire, silver fabric into garments that provide user interference, they tone muscle. So it's something that I'm kind of comfortable with, it's something that I'm familiar with. But for this project, I wanted to try to create something that was universal rather than individualized. It's just because I come from an industrial background, I'm so used to, how do you make it quicker, how do you make it faster, how do you make it smaller, and how do you make it universal. So in researching active aging, I looked at the group of women that I'm involved with. It's a group, we do textile projects with local people, getting them to embroider, getting them to sew, telling their stories, all of that. But one of the common things is we're all postmenopausal, we're all older, we're all sweatier, and we're all clanging. And one of the things that drives us all insane are smartphones and smart technology and touch screens and having to do everything quickly, and we've got to answer the phone in 4 rings, and if you don't swipe, your bank is going to cancel your transfer, and we all get panicky. So we thought to try and dumb down technology, and my idea was a simple tactile textile button that when your phone rings, you can hear it ringing. You tap your phone, just a quick tap. If you're gardening, your hands are dirty, you don't have to worry about the screen. If you're skiing, you can hit it a slap. If you're cycling, just touch it and it answers your phone. That's literally all it do, is answer your phone in its current form, and it doesn't even do that. It just provides haptic feedback so that you can understand. But it can be, is it a gyroscope, is that what you call it? It can alert you if you fall slowly, and you can use it if you're hiking or outdoors. It can use a GPS locator, so people can find you if you go missing. So it's basically dumbing down everything. It's a big red button. And it's synthetic, everybody. It's plastic. So I work with a team of people that I work with at the moment who are sort of medical engineers, electronic engineers. So the embedded engineer helped me with the software, which is a whole massive field. You know, he just talked me through what he was going to do. I don't think I learned anything because I don't understand. You know, I just go, okay, that's your job, you do that. But then Jacinta at Limerick did all the 3D mold shapes for me, because to get that soft form, I needed a 3D mold. So I used Portuguese technology with the gelatin and the glycerin. I used that and a lamp, a bulb, just to begin the first ones. And then once I learned how to do that, the mold Jacinta made for me, I used them to create the 3D form. So basically, it's just a soft button. Ignore that one because the battery's dead in it. But this would be your button. That part sits against your wrist or wherever you wear it, and when you press it, it vibrates. Just provides haptic feedback. I lift it open so you can see this fabric here is silver coated nylon, and that's something we use a lot in the electrode and that medical device technology. So it literally just at the moment just provides haptic feedback for an incoming call, but it could provide outgoing feedback for GPS location or help. I've fallen down and can't get up type technology. So that's it, simple and universal. In terms of the material I used, basically everything I had in the box was scrap from work. I used a neoprene, a 3-ply fabric. The outer ply is just a regular single jersey. The inner one is a foam, and the liner part is like a 3D open structure, so that when you form it into a concave or a convex shape, it holds its form. I used a product called Framas from Italy, or Bemis in France. It's a TPU that heat forms. So you've got to activate it with heat, you've got to mold it quickly, and it comes in 1-ply or 2-ply, and this is just an old dress of my own that I cut up and recycled, and then digital cutting technology to cut out the on-off switch. The light is actually the top of an oil can. I was gone a bit MacGyver trying to do everything in Sweden, chopping up things and pieces myself. So yeah, so that's what it is. It's just an on-off switch made from textiles. That's got a nice, apart from the haptic, it's got a nice touch. Yeah. So that's mine.
It was nothing useful. No, I was just...
My study started more into the realm of technology and the way we communicate with technology. So if we think about all the devices that we own, laptop, computers, smartwatches and phones, they all communicate to us and they all need to get our attention through ringtones, vibration, visual pop-ups. Most of the times we don't realize, or maybe we do realize, that we are a bit overwhelmed by like all of this stimuli. If you think about like when we leave our phone on a table, then we see like all of this pop-ups, and then it's ringing, and then it's vibrating. So the question at the very beginning of the study was, first of all, do we really need all of these alerts, or can we think of different level of urgency when technology is speaking to us? So maybe we have tech moment, like events that need to be communicated right away, a phone call from my doctor, a phone call from my lawyer, or maybe we also have like secondary alerts, such as like a like on Instagram, a like on a Facebook post. So I try to translate, so it really started from analyzing the way I do interact with technology, and then I try to, of course, take it into the age group that we are focusing on, and of course this principle all apply, and in a sense they all get very amplified. So this silly study is on investigating other alternative ways to communicate, alternative ways that our technology can use to communicate with us. This is a shape-changing interface, meaning that each one, I'll just replicate on this. Each one of these scales, they do act as an open and closed lid. So there's a small vibrating motor, a small servo motor underneath, and the servo motor can be activated individually. And each one of those, they can open up in a different way. You can see it on the video. I didn't put electricity here because I'm a bit scared. I designed and built the electronics, so I didn't want to set the place on fire. So the idea is that you can use your own body, your garment. Maybe this is still a very speculative piece, but the idea is that really we don't need. We can have something that is more integrated with our body that communicates with us. So I studied different scenarios. Each one of these also has a small light, a small LED which is built in. So using really like the movement of this sequence to communicate calmly that you're having, like maybe an email incoming or something like that. As said, this is still very speculative. There's a lot of. If I had more time, I would definitely go and investigate more scenarios, more different different applications. And then when it comes to the look and feel, then I wanted it to look as a not a medical device, because if we think about electronics for elderlies, we always have like big red buttons. Salvavita Beghelli is very popular in Italy. My grandpa had it, and is a huge press button that you put in as you wear it as a neck piece, and will give a call to in that case it was to my father, to one person. But it looks plastic, it looks industrial, it looks like an industrial design piece from the 70s. Mm-hmm. So what I tried to do was really, I'm not a fashion designer, but I did this exercise in trying to use felt as a, a more gentle material to integrate technology onto the body. But still, like underneath, you still have all the technology, all the sensors, but the look and feel and eventually the touch of this is a bit more gentle than what we are used to. Yeah, I think this was it. I'm very happy to take any questions and comments.
It's time to stop saying that you're not a fashion designer.
Yeah. I'll put it up on my portfolio. Okay, thank you very much.
Good morning, I'm Marianne. I'm going to present you my fusion project that I've called Touch on Touch. The main aim of my project is to help older women, both cis and trans women, feel physically attractive, confident and empowered in order to improve the quality of their well-being and their sexual activity pre and post-menopause. So I'm proposing to create undergarments with different tactile behaviors, such as shape change, skin stimulation, that create vibration or pressure. This touch sensation aims to have a really positive impact on the brain and relieve stress, mood swings, unhappiness, sometimes the absence of a sexual partner, or the fear of having painful sexual intercourse.
The title of my project is Mending Futures, exploration of domestic mending in fashion through material methods and participatory textile making. It aims to contribute both academically and practically to the study of mending practices and the envisioning of alternative mending futures understood as a transformation that takes place from now on. My background is in industrial design and eco-social design, which had a strong focus on design research integrated with social sciences. So I'm taking this approach and try to integrate it with my practice as industrial designer.